In this video, in the data visualization series, I'm going to be telling you about what goes on in my head every time I see a new visualization of data. And it's really important that I tell you this because with great power comes great responsibility. Now that we have the capacity to collect massive amounts of data, to do all of these fancy analytics, to make really, really nice visualizations, it's important to keep track of a couple of things that should be going on in your head every time you see a visualization. And so what I usually do is I call this the buyer beware section of the video, or how to spot a deceptive plot. And what it boils down to is the following observation. When you're looking at a plot that was made by somebody else, I always think to myself, what is their agenda and what are they hiding? What are they selling me and what they might be hiding, okay? And if you ask yourself these questions, you'll be able to spot things in some of these visualizations that point out how fishy some of them are. Okay, so I'll start by a really simple example. Here is a visualization of interest rates as a function of years from 2008 to 2012. And if you're just looking at it, the first thing you see is, oh, it's going up. It's going up by a lot, right? But what you're not seeing, as obviously, because they have obviously tried to hide this, whoever made this plot, is that the vertical axes only go from 3.14 to 3.15. So we replot exactly the same data with different vertical axes and including 0 on the vertical axes, you can see that in fact interest rates over these number of years is not really changing that much in the grand scheme of things. And so just by manipulating simple technical things like the vertices and the range of these plots, you can really try to trick your viewer into coming to a very different conclusion of exactly the same data set. Here's another one that I like looking at because it's also deceptive. It's related, but it's slightly different. Here we're looking at the number of customers under 40 and the number of customers over 40 that it's kept track of in some kind of retail store over these months in a calendar year. And if you're just looking at the plot, the first thing you might see is, oh, they're kind of comparable. They're kind of the same, and they're going up and down together, right? What they're hiding is that this is a really cool, tricky type of plot where there's two different vertical axes. There's these numbers, which apply to the dark blue lines, and these numbers that apply to the light blue lines. And if we plotted them on the same axes, the same data now looks like this. And what you're seeing is that really, you mostly have customers under 40, and there's very few customers over 40, and it's not changing that much as a function of the number of year. As the months of the year. And so these two plots tell very different stories. And if you are able to spot some of the tricks that people play when they're trying to deceive you, sometimes you can call them all out on it. So here's another one that's a fun plot. This is an older plot that I'm taking from Edward Tufte's classic book on data visualization, The Visual Display of Quantitative Information. This book is probably the first one to treat the visualization of data in a serious way. And all of these visualizations had been made by hand because this is before the age of computer-aided design. But the point it's making here is remarkably clear. So what we're seeing here is the price of oil per barrel for these number of years. And when you're looking at the sizes of the barrels, which is what we look at because we're humans and we look at sizes of things, you're thinking, oh, look at how much it's changing. This barrel here is really tiny and this barrel is really, really gigantic. It's probably hundreds of times larger than the first barrel. The price of oil must be changing a lot, right? That's my intuition when I'm looking at an infographic like this. But it's being really deceptive because it's not clear how they're drawing the sizes of these barrels. Are we looking at the height of the barrels? Are we looking at the diameter of the barrels? Are we looking at the volumes of the barrels? These things really change a lot depending on what is the relevant quantity that we're changing here. And so especially when you see kind of cool infographics that look interesting and that you want to look at because there's some visual interest in it. This is not a boring bar graph. It's a bunch of barrels of oil, and that's relevant to the topic. Try to think, what is their agenda and what are they hiding? And are they actually telling you the information in a sufficiently honest way that you can draw some kind of conclusion from it? In this case, I would argue that they're clearly trying to deceive the reader into thinking that the price of oil is increasing more than it actually is over these number of years. Here's another one that is a really common thing that you see is that there's a correlation between something and something else, right? Oh no. Usually it's an oh no. Very often it's an oh no instead of something good has happened. So here we're seeing two plots. The first one is just showing the correlation between US spending on space science and technology versus the number of suicides by hanging, strangulation, and suffocation. And there is a beautiful correlation here over these number of years that they're both going up. On the bottom here is a slightly funnier and more ridiculous one, which is the number of people who drown by falling into a pool is very well correlated with films Nicolas Cage has appeared in. Look, they even go up and down together. They increase and decrease together from year to year, okay? So what it's pointing out here is that even though there's this mantra that we all have heard of, that correlation is not causation, everyone has heard this, it's really hard to internalize it. It's really hard to internalize what that really means in terms of interpreting data when you see really convincing graphs like this of data that goes up and down. So here, we all have this intuition, right? If you think about it really critically, does Nicolas Cage really affect the number of people who drown by falling into a pool? I mean, surely that cannot be true, right? So if you apply your expert knowledge, in this case of knowing pop culture, knowing causes of things, you can say that this plot here is trying to deceive me. This gets harder if these are technical plots of quantities that were measured by sensors somewhere else, right? But nevertheless, I'm trying to argue that the same filter should be on in your head where you should be thinking to yourself, does this make sense? Does this fit my intuition of what else I understand about the system that I know that I've been studying for a very long time? And if it doesn't fit with that intuition, it doesn't mean it's wrong. It just means that you really should be examining it much more carefully. Maybe make some more plots, maybe ask different questions. Maybe go back and look at if the data was right. Be really discerning about these kinds of things. And so there's a really interesting illustration of this effect that I like showing. And it's this paper where they put a dead salmon in a functional MRI scanner and showed it pictures of people in social situations and alone situations. And so the idea is what part of the brain correlates with looking at pictures of social situations versus alone situations. Now, this is the dead salmon. In this experiment, they were just calibrating the machine, and so they went to the grocery store, bought a salmon, put it in the tube just to see what they could scan. This is not the actual experiment, right? But the point they're making here is if you're not careful about what you're looking for, you can actually find a part of the brain, this right here, this part of the brain, of the dead salmon's brain, that responds very, very significantly in a statistical way, if you're doing the certain stats in a certain way, to these two social situations, right? And the point we're making here is that if you have a sufficiently large pile of data and you're just looking pairwise for correlations between anything and anything else, you are guaranteed to find beautiful correlations. And it doesn't mean anything at all. So in order to really learn things, you have to use correct for this multiple comparisons because you're making many, many comparisons. So the chances of you finding something at random increases. And the second thing that I would also point out is that this is kind of an absurd argument for really using your intuition of what you think ought to happen when you're interpreting data. You can really easily be misled by beautiful graphics, be convinced of something that's not true. But if you pause to think about it, is this actually what I think should happen? Is this useful to me? Are there things that I would like to ask for in addition to convince myself that the thing that you're showing me is in fact correct? That should always be going on in the back of your head as you're looking at visualizations. So there's another version of this that I want to point out, because earlier in this video series, I showed you a couple of really useful ways that we can use networks as data, especially visualizing these networks in order to gain intuition, to make predictions, and to help us understand these very complicated systems in a better way. And so this is a kind of a double-edged sword here, because networks of data are pervasive, and they're super useful, and they come up anywhere. But visualizing networks is difficult. So what I'm showing you here is a visualization of the same network, the same underlying relationship, the same number of nodes, the same number of edges, the relationship between them, all of them are exactly the same. And all that's different is that they're being visualized in 8 different ways. And they look totally different, like completely different, right? You would never have known, visually speaking, that these 8 networks are the same network. Because our visual cortices in our human brain are not made to interpret this type of data easily. And so this is one area of data visualization that should be tread on with much care and discernment, because it is really easy to make your network data look a certain way because you're trying to tell a story and deceive whoever you're trying to tell the story to. And so the buyer beware story version of the network visualization is the following. If you're not careful about how you're visualizing your networks, it might as well just be a hairball.